Here's the code I'm actually giving you for the assignment. Let me just give you a little tour of it. So it's called minheap, and it's over a type that can at least compare itself with other instances of its type. So as you remember, those are appropriate for doing comparisons for less than, equal to, and greater than. It implements the priority queue interface. I went ahead and put in a priority queue interface with these simple public methods: isEmpty, insert, and extract min. Remember that the decreasing activity happens by the decreaser, and so let's take a look at decreaser. So when I create a decreaser for an object, it stores the thing, so it could be an integer or a string or whatever it is, and it also remembers the location where that's initially stored in your heap. And decreaser has to keep that information up to date, or rather you have to keep it up to date inside of minheap. So in the constructor, we store away the information correctly. Decrease, when called on a value, looks to make sure that you really are decreasing, and if so, tells the heap to decrease it. Now in response to that, and there's comments about this in the minheap implementation, you need to be able to update the lock information from within minheap. So let's go back to minheap and talk more about it. Okay, so the constructor makes an array with enough elements. Remember that because we're burning element 0, we have to actually create one more element than usual. And size is 0 when we start. That seems appropriate. So inserting a new thing into the heap, as I talked about in lecture, we put in belongs at the end of the array. That is, where size would currently be. And so what insert needs to do is to create this handle, this decreaser object, and there's the call to decreaser, with the thing that we're inserting, like a string or an integer, whatever this particular call is doing. And then we store it at the location, which is 1 greater than the current size. Well, it's at the current size, I'm sorry. We store it where the current size is, and then plus plus, no, I have that wrong. Hang on. So we store it one location past the current size. That's what plus plus size will do, it pre-increment size. And then that updates size as well, so that's in one gesture. And what you have to do is now put this ants in your heap array, and the array's been provisioned up here as an instance variable, and it was allocated here in the constructor. Okay, so you have to put this ants thing at the end of the array, and remember in class we ended up reducing insert to decrease. It's as if the element that's at the current value of size used to be infinite, and now it's decreased to the value of thing, so decrease can take care of that. Okay, so here is the decrease method, and there's lots of comments about that. And what's important, and I said this earlier in this video, is that if the location of an element moves around in response to decreasing something, remember decreasing something causes it to swap perhaps up the tree. So if the decreased thing is too small, it needs to swap with its parent and with that parent's parent and so on. And as that's happening, the information inside the decreaser object has to be updated. If you fail to update it, my checks will catch that and you'll get an error, and hopefully you'll know what to do about that. Here's extract min. The minimum element is always at the first heap location, which as you know is 1. We burn location 0. And that creates effectively a hole at the root, and you have to do what's described in lecture to address that, which includes swapping the last element with what was at the root, and then placing it there, and then calling heapify. That's all in the lecture. And then here's the private heapify method. Heapify is never called from outside. It's called in response to putting something at the root that may not belong there. It may have to be pushed down as that happens. And of course, heapify will call itself whenever that situation occurs again. The same thing that I set up here about updating the decreaser information that's in this paragraph here also holds for heapify. So if anything ever changes location, it needs to update itself in the decreaser object about where that object is currently stored. And after that, I have methods that I've implemented for you. isEmpty was simple. And there are methods below that are needed by the testing and validation infrastructure. Whenever you call for the toString of a heap, I'm going to print it in that nice form that I talked about in the other video. Now if you run your main method, let me run the one that's actually solved, which is down here. what it's going to do is it's going to prompt you to make sure you really want to run it, because I think more often than not you want to actually run the JUnit test. But if you do want to run the main, it does do something. So what it does, let me go to the top here, is it keeps inserting elements in the heap, and you can see 766 was the first element. Then 358 was inserted. That would have been underneath 766, but then because of decrease, it would have swapped. It looks like 155 came next. 155 would have gone as the right child of 358, but because the heap condition isn't satisfied there, decrease is going to cause it to swap with the right child. And you see the result here, and the tree just keeps growing and growing in response to adding things to it. I think there's about 50 elements, or maybe 100, I forget, that are added. And once those are all in place, let me zip down to the end here, it just then does extract min. And here's all the extractions, and they should come out in sorted order. I'm scrolling up now, sorry. Let me go up. Okay, so here's what happens. Here's the original heap, and you can see perhaps that 1 is the minimum element. It's the root node here. It's got 25 and 26 as its children, but 8 is stored. Let's see, where is 8 stored? Okay, so 8 is actually stored over here as the right child of 1, and the left child is 25. So after 1 is removed, 8 is going to end up being placed at the top after heapify is run. So we take out 1 and then 8 and 25 and so on, and these are being extracted in sorted order because I'm calling extract min repeatedly. It looks like there's about 100 numbers or so. Okay, so that's it. Good luck, and of course ask questions.